Good afternoon, class. So at this point we are looking at calculus. You guys had homework, correct? Which page are we on? 160. Page 160. We do these examples here. On 160. You sure? Okay. So on exercise, did I ask you to do exercise 8? Okay. Any problems with number 1? Exercise 8, number 1. Yo, just close the door, man. You don't mind. Good. Where were you last week? We missed you last week? Yes? Weren't you absent? Fridays. Why did you guys stay home Friday? So Thursday was holiday. Oh, sick of us. Are you feeling better now? Good. Not the maths making you sick. You think so? My what? This is the one thing that makes me better. When I'm sick, I do maths. I do easy equations, no, not the difficult ones. Right, here we go. If people, any problem with number 1? Determine the equation of the tangent at x equal to 2. First derivative, set 2 into the equation, I get the gradient out, put 2 into the f of x, I get a point of intersection out, and I work it. Yeah? So you have no problem there. Huh? No. 1.2. Is f an increasing, decreasing, or stationary at 2? So, what was the equation of the tangent? Sorry? So y is equal to 24x minus 30. Minus 30. Okay. So 24x. Must be at 4 here. 20. Then that point is about here. That's basically the tangent we have calculated was this line. Okay? Is f an increasing or decreasing stationary point at x equal to 2? Huh? Increasing. Not so? Because as x increases, the value of y increases. Can you see that? Is this increasing or decreasing here? Increasing. Yeah? Decreasing. Can you see that, people? So it's increasing. Then justify the answer. The gradient is positive, you can say, or as x increases, the value of y is increasing. Okay. What's the answer they have at the back of the book? Just check at the back. What was the justification? What did they say? Sorry? F prime x. Yeah, f prime x. Here they're saying that f prime x is more than 0, which is the gradient is more than 0. Not so. Since the gradient is more than 0, the graph is increasing. So if you look here, okay, just make this note here. No? There's your turning points. Here f prime x is more than 0. Can you see it's positive here? Here the graph is increasing, so f prime x is more than 0 there as well. If you look from that point there to there, then f prime x is less than 0 or negative. You guys understand? What happens at 0, at this point here? F prime x is equal to 0. Here, f prime x is equal to 0. Make that note there. And I'll do the reverse now on the other side. Or below that, okay. Okay, that's your turning points. Here, f prime x is less than 0, the graph is decreasing. F prime x is less than 0, the graph is decreasing. F prime x is more than 0. From, just put that in black again. From there to here, f prime x is greater than 0 or increasing. Okay? At the turning point, f prime x is equal to 0. Neither increasing nor decreasing. So make that note there, people. Danica, you went to class on Saturday?
Yes, but the car was a place.
Oh my word. So you had to ask the other maths guy first. Huh?
We just put into the info also. We were independent.
So you don't have to ask questions.
No, it was a subcourse.
A full class? How many people was in that class? 14.
Because our teacher wasn't there, so they said we must work there.
Oh, okay, nice.
That guy was telling me about this. He said the other note of the state doesn't offer such opportunities for the children.
But now he's taking that opportunity away from you by not teaching you. Did you speak a whole lesson about it? Half? Did you rock you half of the lesson? You see why they don't do this in the north? I'm just joking. He's the guy from, okay, the brother don't mention. Okay, so let's go back. So now in 1.3, determine the equation of the tangent at x equal to minus 1. What's the equation of the tangent at x equal to minus 1? Y is equal to? 9. Straight. So the gradient here is 0, not so. So if you take that into account, and they ask you to draw this in, then that's actually going to happen here. So your gradient is 0 here. Can you see that, people? It won't be here because that's on the positive part of the x-axis. Can you see that? It's a negative part, so that is y is equal to 9 here. The question is f increasing, decreasing or stationary? It is stationary. The gradient is 0. When the gradient is 0, we are told that the point is stationary. The turning point is a stationary point. Okay? Look at the next one. 2. It's fairly large. People, you will only appreciate this explanation of the answers is if you had done your homework, okay? So some of you are thinking now, what is going on here? No? I can hear you asking yourselves those questions. But if you didn't do the homework, then you will be lost. Okay? People, they tell you number 2, consider the function f of x equals 4 over x minus 2. So that is a hyperbola function there. The question says, find f prime x stating your answer with positive exponents. So that, you say f prime x equals, so firstly this can be written as x, 4x to the minus 1 minus 2. So your derivative thereof is going to be negative 4 over x squared, and the constant falls away. You all agree with that? Right, the next one, determine the gradient to the tangent at x equal to 2. Okay, so what did this work out to be? It's negative 1, yes? Is that it? Oh, this was a gradient, sorry. I thought the one, the tangent. So x is equal to? No. Determine the gradient. So f prime x, sorry, f prime of 2 is going to be negative 1. Which means you say my gradient is going to be negative 1. Is f an increasing or decreasing function at 2? If I look at my x-intercept here, x-intercept at y equal to 0, so that point is a half there. You all agree with that, no? X-intercept at y equal to 0. So I'm just trying to make sense of what is asked here. At x is 2. Not a half, it's going to be 2. Okay. So reading this 2.3 now, is if an increasing or decreasing function at 2. So if I draw a line here, it will be a decreasing function. Can you see that, people? It's decreasing at 2. Or we can say as x increases, the value of y decreases. Okay, so it's decreasing function. Determine the equation of the tangent of f at 2. So y is equal to negative x plus 2. Okay, there, that's the point we're going to substitute 2 and 0. No? So if you put 2 into f of x, you get 0 out. Determine the gradient of the tangent at x equal to minus 1. So minus 1 will be approximately here. That's what they're looking at. Okay? Determine the gradient. The gradient is going to give you negative 4. If you put minus 1 into there, you get negative 4. Is f an increasing or decreasing function? So of course a decreasing. Determine the equation of the tangent at x equal to minus 1. What was this? Y is equal to negative 4x minus 10. This is when you substitute this negative 1 and was it negative 6? Is that correct? Negative 1 and negative 6 was substituted in them. Will f ever be an increasing function? Will f ever be an increasing? Can you see here the hyperbola is always a decreasing function, not so. But besides that, will if even be an increasing function justify your answer? Since you're busy with calculus, we're going to try and answer it in terms of calculus. Okay. The function is increasing when the gradient is positive, and the graph is decreasing when the gradient is negative. If you look at this gradient of this graph, f prime x is negative 4 over x squared. You see, since x squared will always be greater than 0, not so. X can't be 0, no? Why can't x be 0? It will be undefined, not so. But if you look here, it can't be 0 because there's an asymptote here anyway. Okay. But you see, x is always positive. Can you see that? Why? Choose any number for x. Choose a number for x, any number? 7. 7 squared is 49, which makes it positive. Choose another number. Negative 7. Negative 7 squared, positive 49. So whichever number you choose for x, x will always be positive. For x is an element of real numbers. However, if you're looking at negative 4 over x squared, what's a negative divided by a number that's always positive? Negative. So that will always be less than 0, provided x is not equal to 0, for x is an element of real numbers. And then we just explained now that since the gradient is always negative. Therefore, for all values of x, the gradient will be negative. Therefore, this graph will never be an increasing function. Does that make sense? Right, moving on swiftly. They ask you to do number 3 as well. Okay, any issues here? Consider the function, right? That. Determine the derivative of. So it's the same thing they ask you. Derivative, once you got the derivative, is your general gradient. They wanted at specific points, you substitute those values in to get the gradient out of that point. Substitute that same point into the function to get the point of contact. And then we can substitute in the form of the equation y is equal to mx plus c. The derivative gives us the gradient of the tan. This is now, let me just copy this. So there's a note you guys can write down at home. It's important to note that the derivative gives the gradient of a tangent to a curve at a specific point. That we know already. Yeah? If you know the value of x, you can work out the gradient of the tangent at that point. The value of x that is given. If you know the gradient of the tangent, you can work out the value of x at the point of contact. So just taking that into mind, if you look at this here, okay, and we say, okay, at which point, at which value of x is the gradient equal to minus 1? But we must now work out the standard form of your gradient. We worked out the general gradient, which was negative 4 over x squared equals negative 1. And here we can now solve for x to work out the gradient at which that will occur. Just coming back to this, if you're going to work this out, you're going to get x squared is equal to 4. So x is equal to plus minus 2. But you're going to say, but hang on, there's two values here. Not so. Which means to say, if I take this graph here, see that x is equal, this tangent here, at 2. Somewhere along that curve on that side, you will have the same gradient of negative 1. Can you see that? And at which point, which x value will that occur? Will occur at x is equal to negative 2. Can you see that? This one being a positive 2, and there being a negative 2. You see that, people? But take the other one into account, which is, there's not a straight line here. Drawing is bad. Let's take a straight line there. Okay. So this is a gradient of negative 4. See, somewhere along there we'll have another gradient of negative 4. Can you see that, people? The gradient of the tangent to the curve at that point. And that is something you must note at this point. Okay. A stationary point and turning point, the tangent is horizontal and has a gradient of 0. I've indicated that way when we drew these graphs here. Okay. Remember that at the turning point your gradient is going to be 0. Alright. Let's carry on. The example on page 160. Okay. So consider the function, you got f of x equal to x squared minus 2x minus 15 and g of x equal to x cubed minus 7x. The diagram is given. Okay? The question says determine the value of x and the equation of the tangent if prime x is equal to 2. So here f prime x is equal to 2. So what is this? This is our, what is that, people? That is your gradient. Not so? So that's your gradient, not so? Your gradient of 2. The question says determine the value of x and the equation of the gradient. So if the gradient is 2, how do we get to f prime x? How do we get this here? You take your first derivative here of f of x, not so? So your f of x is equal to x squared minus 2x minus 5. 15, okay? Sorry about that. So what do we say now? F prime x is equal to 2x squared minus. Okay, we are at this point in our lives again. Okay. So it's going to be 2x minus 2. We apply the derivatives by rules here. Did they ask us to use first principle then? No. So I don't have to use first principles. Okay. Derivatives by rules is easier. Okay. It's only when they ask us to apply by definition or by using rules of definition or first principles that we do that long process. Okay. So if prime x is equal to 2, so that means to say that 2x minus 2 is equal to 2. Can you see it? If prime x is equal to 2. So what does that allow us now to do is to solve for x. So x is equal to 2. So what does that mean? Can you see that the f graph is your parabola? Okay. And your gradient is 2, which means to say must have a positive gradient, which means to say if I draw it against the graph thing, it will be at x is equal to 2 that this is going to be the case. Can you see that, people? You will understand. You guys understand? Yes. Pray for each other. Huh? Please pray for me. I'll survive this year with you guys. Okay, so let's look at it again. So if prime x is equal to 2, that means that the gradient is equal to 2. But if prime x is your first derivative, we worked out the first derivative, and we set that equal to 2. So this is our general gradient anywhere along the curve. By setting that gradient, the general gradient, equal to the gradient, I get the x value at which that occurs, which is x is equal to 2. Now the question was to work out the equation of the tangent as well. So for the tangent, we know it's going to be in the form of y is equal to mx plus c. However, m is given as 2. So y is equal to 2x plus c. Now to calculate c, I need to know the point of contact. Or we need a point on this curve, on the line, sorry, on the tangent. And the only point on the tangent is this here. So now we substitute 2 into the quadratic formula, which is 2 squared minus 2 times 2, which is 4, minus 15. So that is minus 15. Which makes sense, okay? So that point here is actually in line with this here, as I'm seeing that the y-intercept is negative 15. Okay, but doing it is just giving you an idea of what's happening. Okay. So what do I do is I substitute 2 and negative 15 into the equation, and I get negative 15 equals 2 times 2 plus c. So 2 times 2 is 4, you take it over, becomes minus 4, gives you negative 19. Therefore, y is equal to 2x minus 19. Alright. Okay. (1.2). You are told that f prime x is equal to 0. So your derivative is equal to 0. When is your first derivative equal to 0? When you're busy with that? Yes, well done. Okay, to do with the turning point. So, your first derivative, which is 2x minus 2 is equal to 0. Take that over, so 2x is equal to 2, so x is equal to 1. Which means to say that this, you see your axis of symmetry here, the x value at which this occurs is x equal to 1. But we could have done that if you look at the way we normally work out axis of symmetry is minus b over 2a. Not so. So it's negative minus 2 over 2a, which is 1. So that's going to give us 2 over 2, which is 1. Can you see the same answer? So now, when you want to work out the turning point of a parabola, we don't have to go minus b over 2a anymore. What do? You apply your derivative, first derivative, and set it equal to 0. Why? So your first derivative is your general gradient. By setting it equal to 0, you'll work out your turning points. Okay, so you can apply your derivative to that to out your axis of symmetry there as well. Okay. So the gradient of this graph is going to be, of course, y is equal to 0x plus c. So that falls away. So y is equal to c, in other words. So we need to know this point of contact here. Not so. Because if you take the derivative into account, going through that point there, the derivative going through that point, what we do is we substitute 1 into the equation of f, which is 1 squared minus 2 times 1 minus 15. So we give you negative 16. So what's the equation of this tangent? Y is equal to negative 16. This is paired out to your x-axis, so there is a constant y leading. Okay. Let's do the next one. (1.3). G dash of x equal to negative 4. What does that mean? That means to say that the gradient on the g of x graph is negative 4. Okay? So let's go with g prime x. So g of x is equal to x cubed minus 7x. So g prime of x is equal to 3x squared minus 7. Okay? So g prime x is equal to negative 4. So negative 4 is equal to 3x squared. What do I do now? Bring the 7 over. Gives you 3. Okay? Divided by 3 both sides. So x squared is equal to 1. Square root thereof, x equal to plus minus 1. So we put we look at the graph and see what they actually mean here. It means to say that if x is plus or minus 1, if we look at the parabola, at the cubic function, which is the g of x graph then, and you draw a gradient of negative 4e, of course it's going to be a steep gradient there, not so. If I put that there, can you see? I can have x is equal to negative 1 there, can you see that? And I draw the gradient on this side, same gradient, and that looks about minus 1. So does it make sense why I would have 2x intercepts, or 2x values at which that gradient occurs? Does it make sense? Likewise, if you had gone with a positive gradient for argument's sake, and you take it against that graph in question again, You see here, there it will have that gradient. The tangent will touch at that point only, and somewhere along here it will touch at that point only as well. Can you see that? So for a cubic function, it's just but one value, it won't be that be the case like that. That you will have two gradients like that in this format. If your cubic graph is drawn like this. Okay. Alright, so that explains why there are two values. Now coming back to the equation of this tangent. Okay, we need the point of contact here. Not so? So we say f of minus 1. Remember, this is minus y and some y value, and this is going to be 1 and some y value. How do we get the y value? By substituting 1 into the g of x graph as well as negative 1. So that's going to give you negative 1 cubed minus 7 times negative 1, which is negative 1 plus 7, which is 6. Okay, so the point of contact is negative 1 and 6. Okay. And the other one is f of 1 is equal to 1 cubed minus 7 times 1, which is negative 6. Okay. So it's 1 and negative 6. So you're going to consider this one first. Okay, so you got y is equal to mx plus c. M is going to be negative 4, so negative 4x plus 7. Plus c. We'll substitute negative 1 and 6. So x and the y. So 6 is equal to negative 4 times negative 1 plus c. C then works out to be 2. So therefore the one equation is y is equal to negative 4x plus. Okay. On the other hand, we're going to use 1 and negative 6. Again, the standard form will be y is equal to mx plus c. Your gradient is known to be negative 4. To work out, say I substitute the point that the graph cuts the tangent, which is 1 and minus 6. Okay. So negative 6 equal to negative 4 times 1 plus c. So c is minus 2. Y is equal to negative 4x minus 2. Okay. In the next question, in number 2, for which value or values of x, or they say solve for x for which f prime x is equal to g prime x. What does that mean to say? That means to say that the gradient of the f graph is exactly the same as the gradient of the g graph. You see that? The gradients are equal at which point? So f of x, we worked out that gradient already, which was 2x minus 2. G of x's gradient, which is 3x squared minus 7. So they are equal to each other. So therefore 2x